Hi, my name is Markus Laattala. I'm a doctoral researcher from Aalto University, and I'm presenting our work on the design and evaluation of a new anticipatory movement visualization technique for VR dancing called WAVE. So this is how the visualization works. Here you can see the third-person mixed reality view of the VR project that we used in the study, with the user added inside the virtual world. So, in WAVE there are three parallel lines of model dancers, and the user becomes part of the line in the middle. The user is able to see several of these model dancers with different time offsets, and effectively becomes part of the crowd of making waves, similarly as you might have seen in some sports events. The user can therefore mimic the moves of nearby dancers and anticipate upcoming movements. Also, having more than one of these lines of dancers maximizes the visibility of the choreography. The project itself was made with Unity 3D and uses the MetaQuest tool. The beginner contemporary dance choreography you are seeing was designed for us by a professional contemporary dance teacher, Anita Isometta, with over 20 years of experience teaching students of different levels and creating choreography for them. We chose contemporary dance as our focus, as it is relatively underexplored in dance games compared to styles like hip-hop or other forms of street dance. The inspiration and reason for the design, on top of the lack of contemporary dancing games, was also that even though dance games in general are one of the most popular game genres in virtual reality, effective instruction of dancing in VR remains still partly an unsolved human-computer interaction problem. Those approaches that do exist usually either only instruct movements partially, abstracting away nuances, or require learning and memorizing symbolic notation. In contrast with WAVE, we wanted to investigate how realistic full-body movements designed by a professional choreographer can be instructed on the fly without prior learning or memorization. So, having this as our goal, we defined two key requirements for our design. Firstly, the system should be able to instruct choreography to the same level of full-body detail as can be instructed outside of VR, like in a studio for example. This also means that we cannot rely on something like symbolic or abstracted dance notation. Secondly, the user should be able to follow the instructions on the fly like it is possible in many rhythm games, for example. These requirements lead to design principles of needing to show complex full-body movements and also allowing the user to anticipate future movements, which in turn lead quite naturally to the core WAVE design idea of multiple dancers performing at different time offsets. However, there are infinite ways of arranging the dancers. Aiming to find the appropriate formation, we ran an informal study seeking feedback on potential variant formations. For this, in collaboration with our choreographer, we designed 5 potential WAVE formations. The first one was the formation of 3 parallel lines that would also be the final configuration. The second one had 5 radial lines going towards the user. The third one was similar to the second one, with added faraway dancers for less occlusion for future movements. The fourth and fifth ones had curved lines, with the fourth one having the avatars in a circular formation. We tested these with 10 experienced contemporary dance students. While our goal was to create something enjoyable for both dancers and non-dancers, we specifically chose to seek design phase feedback from experienced contemporary dancers. Our reasoning was that these dancers might be able to articulate their feedback better than novices. We focused on subjective differences between the visualization variants. Every participant tested the variants in prescribed order at their own pace using 2 different choreographies. By pressing a button, they could loop through the variants as many times they felt they needed to explain their thoughts and rank the variants. None of the variants was clearly better than others, and the participants had different and often opposing opinions. However, the variant with 3 parallel lines was slightly more preferred on average than the others. It also did not have problems with occlusion or the same problem of dancers moving too early as there was with the fourth and fifth variants. Next, to evaluate the chosen wave variant, we conducted a user study. In it we compared 36 participants to see if they followed the choreography using wave more accurately compared to the baseline, with a single model dancer whose movements the player should copy. Each participant danced the same choreography using both conditions in counterbalanced order. We tested two hypotheses about the suitability of the proposed visualization technique. The first one is that wave allows players to perform choreography more accurately than the baseline. And the second one is that users should have higher subjective assessment of being able to perform the choreography correctly. During the study, we collected some data from the participants. Before dancing, we asked the participants' age, gender, VR experience, dance experience, and experience with dance games. During dancing, the participants' head and hands were tracked using VR headset and hand trackers. This data was used to calculate position and direction errors, allowing quantitative comparison between the players' movements and the desired choreography. At the end of each experimental condition, users were instructed to indicate how they felt about their subjective performance using two sliders using a range from 0 to 100%. The questions were: I felt I was able to perform the choreography correctly, and I felt I was able to time my movements correctly. After gathering the data, we found no statistically significant differences between wave and baseline in these subjective questions. However, both position-based and direction-based movement accuracy had statistically significant differences in errors between the two conditions. This means that wave provides a potentially useful visualization approach for VR dance designers. Supporting the first hypothesis, both the position-based and direction-based movement error analyses indicate that users can match the choreography better when using the wave than when using the baseline visualization. The effect is small for position-based movement error and large for the direction-based movement error. The majority of participants also preferred wave over the baseline. We also found out that when looking at the changes in the direction-based movement errors when the choreography shifted in time, the data shows that in the baseline condition, users were half a second late with their movements on average. Using wave, they were not late but in fact slightly ahead of the correct time, which may indicate that they sometimes paid too much attention to movements far ahead of them in the visualization. This could be addressed in the future work by changing the delays between the rows of dancers in the wave formation. Some other future work could be, for example, to extend our prototype toward a full game. For this, one would need to add clear real-time feedback for how well the user is dancing, such as verbal guidance, for example. Also, to allow the users to see themselves, mirrors could be added to be part of the visualization. Right now, Wave is designed for a single user. However, we could imagine applying Wave in a setting like social VR, allowing dancers to emit their movements as waves that other users can try to follow. So to conclude, in this study we proposed and evaluated Wave, a new VR movement visualization technique aimed at solving how to instruct full-body dance movements on the fly. We built a metaphor of the user being part of a crowd making a wave into a sports event. We use multiple model dancers with different time offsets, allowing the player to both mimic and anticipate movements. To minimize visual occlusion, we render multiple lines of dancers at different locations. Our study comparing Wave against the baseline provided evidence that Wave helped users anticipate upcoming movements and perform choreography more accurately, particularly in terms of more closely matching the direction of head and hands movements as choreographed. Thank you.